Hello, we are going to do questions from the workbook for Math 30-2 on page 26. We'll do number 2, 3, and 4. So question number 2 has two students and they're repainting their homeroom, and they have been given choices of colors. So we have mauve paint, we have lime green, oh my, or pale gold. So this is our color. And they've been asked to draw a diagram tree of all of the choices. So they have those three colors, and then they have two choices of finishes. They can have matte or they can have glossy. And so for each of those choices, they then have a multiple of two more choices, matte and glossy. And finally, they have a choice for their trim. And their trim can either be ivory or cream. And so again, we have a multiple of 2 because we add ivory and cream to each of the finishes. And so this is the diagram tree that we would get. And if we count, we have, I'll just change the color here. If we count, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 choices. And it asks us to use the fundamental counting principle to verify this. So if we think we've got color, we have finish, and we have trim. These are our three options. We have 3 colors, 2 finishes, and 2 trims. And if we multiply those together, we get 12 potential choices. So that's question number 2. Question number 3 asks, for each of the following situations, state whether the fundamental counting principle applies and explain how you know. So in number A, let's read through number 3A. We're going to choose from either a keypad or a touchscreen phone from one of 4 providers with or without data. And so I can see that I've got 3 choices occurring there, and it's clear I've got each stage, so this is going to include the fundamental counting principle. So this would be a yes. And question number 4 asks us for each of these choices, each of these questions, how many options are there? So there, we have a keypad or a touch screen. There's 2 there. We have 4 providers. That means we have 4 here, and we have data or no data. So that's 2. 2 times 4 times 2 gives us 16 possible permutations of choices. Now let's look at number B. B says, drawing either a red card or a face card from a deck of cards. Now, we can, if we start, we go, well, that's a red card and a face card, but what we have to be aware of is that there are red face cards. And so this isn't a situation of this and this because we have intersecting sets. So these are not mutually exclusive, which means no, we can't use the fundamental counting principle. We have to look at each possibility, add them together, and then subtract out the overlap. So we know that in a standard deck of cards, we have 26 red cards. Half of them are red. And there's 4 suits. Each of those suits have 3 face cards, a jack, a queen, and a king. So we have 3 times 4 face cards, which gives us 12 face cards. But half of those face cards are red. And so when we choose our red cards, we're choosing those 6 face cards already. So I can't count them twice. I have to subtract those out, and that gives me 34 ways I could select a red card or a face card. Number C has us choosing pizza and we have regular deep dish or thin crust, pepperoni, mushroom, or ham topping, cheese and mozzarella or cheddar. So again, three clear different choices. This a choice, and this choice, and this choice. So we have our crust, we have our topping, and we have our cheese. And so this includes the fundamental counting principle. And so there was deep dish, regular, and thin crust, so three crusts, pepperoni, mushroom, or ham, so we have three toppings, and mozzarella or cheddar, so that gives us 9 times 2 is 18 different possible choices. So now let's look at D. D has us rolling a sum of 8. And so this is not as clear. There isn't just this and this and this. We have to think about different possible scenarios. And so this does not include the fundamental counting principle. And so if we think about it, we've got two dice, and so on those two dice, we want a sum of 8. So I could have on the first die, I could have a 6, and on the second die, I could have a 2. And if I add those together, that's going to give me a sum of 8. Now, on the first die, I could also have a 2, and then the second die a 6, and that's different, and that also gives us a sum of 8. We could have 4 and 4, and that would give us 8, and we can have 5 and 3 and 3 and 5. And so we have 1, 2, 3, 4, 5 ways that we could roll two dice, and get a sum of 8. And I'm going to post this recording.